Is my screen visible?
Yes.
Yes, it's visible.
Okay, perfect. So, security is something which is not a part of the SDLC. For example, I would say that you are doing some quality testing, performance testing, load testing. These things comes at a particular phase of the SDLC, right? When the developer is ready with the code, he has deployed it in some testing or staging environment, and then the testers come and then they do their tests. Okay. So security is not something like that. Okay, like I will be deploying my code, and after some point in the SDLC, I will say, okay, now it's time for security. No, security is something which starts right from the beginning, while the developer is writing the code in his or her local environment, in the local ID itself, in his or her laptop. There the security part starts. Right from there till the application is deployed into production, as a secure SDLC comes into picture. It's the entire process where you get the security part into the DevSecOps cycle. So, for example, if you see on the screen, right, there are different things like static analysis, code reviews, pen testing, compliance validation, and you can see these all these things are going throughout the life cycle of the application. And while you have deployed, then also there is a security mechanism which is called monitoring, or you can say advanced threat protection. Even if the application has gone to production by passing through all the entire security mechanisms throughout the SDLC, even after that, you need to place some kind of monitoring tool to monitor for the security incidents and security patterns and all, which we'll be learning definitely. But uh, just understand that this is from start to end. That they cannot say that I'm done with security. Okay, it's done. We have tested in the SDLC. So you this diagram, these kind of diagrams you must have seen everywhere on the internet, right? So let's break it down a little bit. Okay, so if you see here, there are different stages. Okay, I have just summarized it for your understanding. So you guys have this idea, right? What is plan, code, build, test, release, deploy, operate? These phases of the deployments.
Yes.
Yes, we have idea of those stages.
Yes, yes, perfect. So while you are planning, no, while you are planning any new application or new microservice, at that time itself security starts. So in the red boxes which you see here, these are the security mechanisms. Okay, these are the security mechanisms which help you to secure your application, and each mechanism has its different role. Okay, so for example, when you start with the plan phase, I I have a new API request, new endpoint request, basically a new microservice I need to spin up in my cluster. Okay, or in my application, there is some modification, some changes where you have a requirement to add a new microservice. So from the plan stage itself, while you are planning, there is a security mechanism called threat modeling. And what this does is this gives you a overview of the threats which you might face in your application. So definitely we'll be studying each and every mechanism in detail, but just for an overview, just understand this, that threat modeling is something where you design your architecture. Okay, you just draw a diagram and you give to a particular tool, and then that tool will give you an output that okay, for example, you have created a microservice and you have exposed that microservice to internet. Anybody can access that microservice on a particular port and particular URL address. So which means that you have a lot of chances of an exploit which comes under the internet facing application. So any internet facing application can get very simple thing, I'll say, denial of service attack. You must have heard about it, right? DDoS attack, denial of service.
Yeah,
Yes.
DDoS.
Yeah.
DDoS. So basically, a lot of requests are coming from different sources to your application. So your application becomes vulnerable to denial of service attack if you have designed it in such a way where it's normal website, okay, normal website which you browse on internet, even those are like vulnerable to denial of service attack. So such things, okay, such things, this threat modeling tool will let you know while you design your application. You draw the diagram and give it to him. This tool, there are lots of tool in market. You can go with any one of it. But threat modeling, so you see right from the beginning itself. So maybe you will say, okay, if I am designing my application in such a way, so we need some protection for denial of service. So see, you haven't started writing the code itself. Okay, you haven't started writing the code, and here only you have determined that my application is a is vulnerable to a potential denial of service attack. How? Because of threat modeling. So if we'll talk in some generic terms. Okay. So for example, you have created a premise, an office premise or a residential premise, right? And you create a flow diagram, okay, from where you are getting in, okay. And for example, you have a gate facing to the road, okay. So if you have a gate facing to a road, then there is a lot of chances that anybody can get through. Correct. So on that side, you need to add grills or some kind of protection where nobody can climb the walls. And you have another gate which is on the another side, but that's inside the colony. So there is another main gate, and there is another watchman sitting there. So if somebody needs to climb that wall, he needs to go through that gate and then climb that wall. Correct. So there is the difference. Both the walls are same, premise is also same. Just the area is different. One is gate facing and one is internal. So you need to focus on the road facing part. So similarly, when similar approach, you just give it to your application, you design it and you put it in threat modeling. And same goes for security architecture review. Security architecture review is like you are inspecting the architecture. Here you are giving the architecture to a tool. Here you are inspecting the architecture. That my architecture is correctly designed, and there are network firewalls. There are no loopholes. Okay, we'll see all these things in detail. But uh, for your understanding, I'm telling you, you start from the plan phase, then you go to the coding phase, then you go to the build phase, and you see these are the all the mechanisms are there which will help you to protect your application. Just the way you said VAPT, correct? You said VAPT. So you see where VAPT is lying here. Most of the people think that a vulnerability assessment, while they do a vulnerability assessment, they are safe. Okay, definitely you are safe because you are checking for vulnerabilities by attacking your own application. But this BAPT is done way after. I would suggest you that, like, it might be like even after your application has gone to production. After that, people go for VAPT because this is done by third parties. Third parties do the VAPT, and they carry out the engagement, and in such a way that they emulate as an attacker. Okay, same approach an attacker would take to attack your application. So while you are doing this now, there are a lot of environments, right? There are development environment, there is testing environment, there is pre-production environment, then comes the production environment. So VAPT you usually do while you have deployed it to pre-production. So you have that vulnerable application running in dev UAT. They can also be get hacked, right? An attacker, if even if your dev environment gets compromised or UAT environment gets compromised, that's a big risk, right? That's a shame for your organization, for your application. Uh, Similar to prod as well. So VAPT, you cannot say that VAPT is the entire security. It's right in front of your screen, right? There are so many security mechanisms. This is the bare minimum DevSecOps model which a company, which an application should have to protect themselves. So this model, as the course our discussion progresses, you will have an idea of each and every phase and the importance of security mechanisms at each and every phase. So any questions with this basic thing, like what is DevSecOps?
So far, no questions today.
Perfect. So I will just move to the next part. like why DevSecOps. Okay, so we'll not just go into that boring theory. We'll just go through the diagrams, and if you have any doubt, you can just point it out. Okay, so I'll just explain you what I am trying to show here. What happens is there is a developer. Okay, he pushes a code. He has some new feature. Okay, he has some new feature to give to the application, and in the sprint he writes a good code and he pushes that code to the release branch. This is the main branch actually, which will get the which will be deployed to the environments. So this branch, there was a vulnerable code. Okay, we'll come to that later. Just understand the flow first. So this is the release branch, and then you run a build pipeline. So this particular code, whatever you have written, and it might be, for example, let's take a Spring Boot example. It might be a jar file. Okay, it's a Java-based application. So you have written a code, and that you run that code through a build pipeline. It creates a jar file and your Docker file. It just combines everything and just pushes to the registry. This is basically the release number or the image which you have built and pushed to the registry. Now there is another pipeline which is the release pipeline. What will happen is you will pull the latest deployment. There is a deployment file, right? If you guys are aware, I'll just stop here. There is a Kubernetes deployment YAML files. Are you guys aware about it?
Yes, we're aware about it, but not in depth.
Yes, yes. No, no issues, no issues. Uh,
Okay.
so this deployment file, you are aware, right? That it is used to deploy, right? It is used to deploy an application to a particular cluster. You configure that deployment YAML to be used. Like it will be having values like the build number, build things, all these things. What needs to be deployed? What is the username? So maybe in the DevOps course, when you progress, you will have an in-depth knowledge and you will be able to write your own deployment YAMLs. So as of now, just believe that deployment YAMLs is something which is used to deploy the application or the microservice to a cluster. It has all that information. So you see here, you have pushed the code. You have build your code. You have created a Docker image, and you are pulling that Docker image, and you are pulling that particular deployment YAML. These two guys are helping you to deploy your application to your cluster. Now you see the deployment goes to the staging environment. Also, if the test all the test goes through here, right? The unit testing, performance testing, load testing, everything would be done here. And once you are done with those things, you go to the production. Okay, so if this particular guy developer has pushed a vulnerable code into this release branch, and this release branch builds that particular vulnerable code and stores in your registry, then definitely whatever you are building using the vulnerable code, that particular thing will also become vulnerable, and that vulnerable thing will be pushed to the cluster, and that is the vulnerable pod. That's how vulnerable pod goes to production, or goes to your staging environment if you do not have a security checks in place. Now, okay, any questions here in this first diagram?
No.
No, so far.
Please feel free to ask. Okay, if you have
Yeah.
any. Yeah. Okay, now let's move to the second part. Now this is something with the security mechanisms. Okay, some same flow with the security mechanism. So these things which you are seeing here, right, is in the yellow. Is it visible, right, or is it too small?
Yes, we're able to
Yes.
see.
Okay, okay. This things in yellow, these are nothing but the security mechanisms which you just saw here at different stages. Okay. So let's come to the scenario where you were pushing a vulnerable code, and now what's happening is you have I have highlighted three things which can prevent this from happening. Okay, at different stages, Okay, so the first thing is the linting tool. Have you guys heard about it? It's just like a spell check. While you type something in your application, for example, take WhatsApp, you get a suggestion, right? You get a suggestion that this is the wrong spelling or this is the wrong grammar. So similarly, a linting tool works. A linting tool, IDE link. For example, if you are writing a code, if you are writing a code and you have written it in such a way that it is vulnerable, then this tool will add a red line under that. Every linting tool will do that only. It will just underline it with a red line saying that there is something wrong, and when you click on that red line, it will give you the suggestion. Okay, you have written your code in this way, you should have written in this particular way so that it's not vulnerable. So this thing is an extension which is installed in the IDs, just a simple extension. For example, the thing which we will be learning in this course would be SonarLint. SonarLint. This is a tool which is just added as an extension to your VS Code or IntelliJ, whatever ID you are using, and it will help you. You just need to install it and it's done. It's done. You don't need to do anything apart from that. So while the developers are writing, they will what they will do, they will validate it. Okay, this my code is vulnerable, so I will not push it to this particular branch. I need to make some changes. This tool you can handle in a central way. Centrally you can handle these tools. For example, there are 10 developers and they have installed this tool in their VS Code. For example, let's take VS Code ID. They have installed this, correct? And you can imply policies that if a particular code has these many vulnerabilities, a developer cannot push this code from his local IDE to my repository, to his feature branch also. So this is the flow, right? He develops on the IDE locally, he tests it, and if the test goes well, he moves that code to one particular feature branch on a repository, and from here he then creates a pull request to the release branch where the leads will verify
Mohammed,
his code. Yes,
yeah,
yes.
sorry to interrupt. Actually, we lost you for like 15-20 seconds.
Mhm. No issues, no issues. I'll
Yeah,
just I'll just repeat.
yeah,
Yeah, I'll just repeat.
yeah.
So IDE lint is there, right? So what this linting tool does is, this is the spell check. This is the spell check, which you usually see the grammar check, spell check in different application, web application, mobile application. So same way a lint tool works for IDE. So how it will work is, you will just install an extension in your IDE and you are good to go. The developer will install this, and while he is writing a code, this extension is active. This extension is checking the entire repository, local repository which you have cloned locally, and while you are typing, it will give you an alert in a way, just the way you get for spell checks and grammar checks. And a red underlined yeah, a red underline. So it will underline that part of code which is vulnerable with a red line. Okay, with a red line, it will highlight, it will underline, and when you click on that red line, it will give you the suggestion. Okay, you shouldn't have written in this way, you should have written in that way. That's how this lint works. Okay, and how this link works, centrally, like you can manage it, you can add policies. Okay, if I have 10 vulnerabilities, okay, or 10 security hotspots, or 10 that underlines which I was talking about, then a developer cannot push his code to a branch, to a repository. Okay, so it works in this manner, right? A developer writes a code locally, he tests it, and after testing it, he moves it to the feature branch in your repository. And from your repository, it's moved to the release branch, and this release branch, this pull request is being then reviewed by the leads. And once it's approved, then the code merges and then it gets deployed. This is the flow, right? But if you see here, if that guy uses uses a tool, a lint tool, in his ID itself, he wouldn't have pushed this vulnerable code to the feature branch. Correct? And here only this vulnerability would be nullified. You would have caught this vulnerability in the earliest possible phase. This is the earliest possible phase where you can catch a security loophole here. Okay. Now let's take an example that this particular application team didn't focus didn't focus on this particular tool. They said, okay, let's forget it. We are not concerned with security at the IDE level. Okay, so forget it. So there is another phase, right, where you add a pull request.
I
You
have a question here about IDE linting.
Mhm. Please do.
So IDE linting is mainly meant to be a security measure, like to fix any vulnerable code in IDE when the developer is writing the code itself.
100% yes, security.
Okay. So it's not simply like a syntax checker or anything like that. It's
Mm,
actually meant for security purpose.
yeah, so the thing which you're talking about here is syntax checker, code spells, correct? There are
Yeah.
linters in the market which does that also, because you need those things also, right? And there are linters which are specific to security. Okay, so the thing
Okay.
which you talked about, right? That syntax check and all ID. So you have ID on that, correct?
Yes.
Yes, so just take that simple example in terms of security. He'll be just pointing out to you the part of code which has security loopholes.
Okay. So these are actually very sophisticated IDE linters, not simply a spell checker or something like that, but they're very
Correct.
more
Very,
sophisticated in terms of secure.
yes, yes, correct, correct.
Okay. Okay. Got it.
So,
Thanks.
we'll be don't worry, we'll be going through each and every tool. I'll be demonstrating it live, so you will get an idea like what's happening. So basically, you can crack any kind of interviews also if you want, like with respect to security. Once we go through the practical part, okay, okay. So
Yeah.
any
Okay.
Sure.
okay, so any questions still here?
Just that. Good so far.
Okay, so now say that they are not using this link tool. Okay, they have said that okay, we are low on budget or any reason, any excessive reason, they have missed this. So there is a scenario where you create a pull request, right, to merge your code from here to here, the release branch. So there is a feature called branch policies. So you just go to that particular branch and you can add policies there saying that if a pull request is initiated to this particular branch, then you need to do these checks. Okay, so these checks, basically you can say that you can run a pipeline. Basically you can run a SAST pipeline. What is SAST? SAST is basically static application security testing. This guy does the same thing which this linter does. Same, ditto, same thing. He will also point you out the tool and all. But this is like in a more UI way. Okay, it's like you will get a proper interface, web interface, and you can look at the codes which are vulnerable, and you can raise issues, you can integrate Jira and all. So basically with using this tool you can do multiple things, and this is just a linter, but both the guys are doing exactly same thing, 100% copy paste. It's just giving you some extra features to manage the security things and all the tickets and integrations and XYZ. Okay, everything else is same. Just these are the extra benefits. So this tool is basically a set of commands where you run a tool. So you can create a pipeline for that. We'll be using SonarQube for SaaS, which will be doing the static application security testing, where it will be doing the code reviews, security code reviews. This tool would be doing the security code reviews while you merge it. So basically, now let's talk about the CI/CD security. Here you can both these things you can add in the CI/CD itself. For example, I am the developer. I push a vulnerable code to the release branch, and this release branch is having a policy which says that whenever a new pull request comes up, you run a SAST pipeline, and this SAST pipeline should pass for the pull request to be merged. This is a condition, which means that your code should be clean for any security related vulnerability to pass this pull request. So if he pushes a vulnerable code, this particular SAST pipeline will fail. SAST checks will fail. As of now, just take the term checks. SAST checks will fail, and if the SAST check fails, your pull request fails, and you are just blocked here itself. Then the security team would be invoked. That developer would panic. Okay, why my pull request is failed? Then he will check. Okay, my code has failed this particular SAST check. Then he will reach out to the security guy, or maybe you can directly create alerts, like whenever this pipeline fails, a security a ticket or a bug is created and assigned to that particular developer itself, and that a security engineer is added as a reviewer. So that security engineer will guide him. Okay, that these were the reasons why your things have failed. Okay, your things have failed, or your code has failed. Now the thing which I was talking in the start, right? The importance of security in DevOps. If this developer is smart enough to understand the vulnerabilities which has come his way, okay, you so the efforts of a DevSecOps engineer reduces. Okay, reduces. So maybe you need a dedicated engineer who just watches out the stash things. Okay, the things which are failing here. So you need a dedicated person, or maybe 2 to 3 hours of his capacity each day to work on these things. But if you have an educated developer, okay, if you have an educated developer who understands these failures, for example, if he sees, okay, my pipeline has failed, and if he checks the results here, these are the results that because of this part of code, my pipeline has failed, and the tool is saying that you should code it this way and not that way. So if he is smart enough to understand this entire process of security, he needs just 5 to 10% of the knowledge a DevSecOps engineer holds to tackle this entire process independently. He doesn't need to ping the DevSecOps guy, okay, my pipeline is again failed and this and that, and bother him. He will just he will just understand, okay, this is the part. He'll just pull the code. He'll do the suggested things by the tool. He'll change his code in a security compliant way, and he'll again push it. His pull request will pass. His time is saved. DevSecOps engineer time is saved, and the company's cost is also saved, because they will reduce on the DevSecOps team's strength if they have educated engineers here. Okay, so this is basically for a developer. So moving forward, for example, say, okay, I don't have this tool also. I don't have a static application security testing tool also, right? In my environment. Okay, so if you see here, the coding phase has passed, where in under the secure coding, the linting part comes up. Okay, under the security mechanism, he has gone to the build phase. The SAST part was able to catch it, but they are not even using a SAST tool. They are low on budget, or they are least interested in SAST. Okay, so now the story goes here in this way, that this particular thing is now deployed. This particular thing is now deployed to a staging environment. Here comes here comes the thing which is called DAST, Dynamic Application Security Testing. Okay, Dynamic Application Security Testing. You need to understand the difference between this DAST and a VAPT very, very, very thoroughly, because they eat you up in interviews with questions related to DAST and VAPT. Okay, so what is a dash and what is a VAPT? Both the guys are doing exactly same thing, but just by sitting, just by sitting at different face of the application. This is internal facing. This is external facing. So first, let's understand what is dash. So this check, SAS and dash, they go hand in hand, okay, with the name, but they are completely different. This guy SAS is capable of catching vulnerabilities in a static code. He will go to the lines of code, 10,000, 20,000, 2,000, whatever it is, and he will scan the code, and he will give you the output. Okay, this part of the code is vulnerable. Why? Why? Because it's written in an insecure way. Okay. Now let's understand. Let's go one step back here. Okay. And let's understand one thing. Are you guys aware about input validation?
No, not really. Is it
No.
a programming concept?
Yes, it's a coding concept. So I will explain you this concept. Maybe I was planning this to.
I, Mohammed, I have a slight idea. I think just tell me if it is right or wrong.
Mhm.
Input validation by you mean, for example, if a variable is supposed to take string, and if you give it a numerical value, integer value,
Yes,
it is not supposed to be. Is it
yes,
that or?
man. Yes, man. Perfect.
Okay.
You are 100% correct. Okay. So this sounds good. You already have an idea about input validation. So, im- just take an example here that you have you have a what do you say? You have an application. This is a, for example, let's take it's a database. Most common. Okay, it's a database. You have provisioned a database as a microservice. You are not using database of any cloud. You are not using SaaS. Basically, you are using infrastructure as a service. You are creating your own database with your own code, own set of codes. Okay, and this database is is communicating. It's designed to communicate with different microservices. Okay, maybe this is the front end, back end, and any particular microservice it's designed to communicate with. But it also has an interface open for developers. Okay, on particular port number, some 5432 port is open on that particular port. A developer can directly communicate with your database, maybe using Postman. You guys are aware about the tool, right? Postman tool.
No,
Oh,
I
okay.
don't know.
Okay. No, no issues. Basically, a simple command line or a dbeaver. Dbeaver is a tool which is used to communicate to a database. So you can basically anyone on the internet can sit and issue commands to this particular database. Okay. So one thing is there. Okay. Uh, let me explain this. Okay. Okay. Let's take another example. Are you able to see my browser screen? I don't think so.
No, we are only able to see OneNote screen.
Okay, okay. I'll just stop sharing
Okay.
and I'll just share the entire window, I guess. Okay. I'm just sharing the entire screen now. Just let me know if it's visible.
Yes, we're able to see the entire screen.
Okay,
Browser is visible.
okay. So this is a input validation thing which I'm gonna talk about. So in terms of security. Okay, so let's take an example. This is the front end microservice you guys are aware about, right? What is a microservice application?
Yes, we're aware of
Yes.
microservices.
Yeah.
Yes, perfect, perfect. So let's take an example that this is the microservice application, and this is the scenario where okay, let's check this. This yeah, we need that. Sorry, database. Yeah, so database is here, and take this database as anything like you have programmed it or you are using Azure based Postgres SQL or any kind of database as your service you are using. Okay, and these are your applications which are sitting inside a single cluster. Okay, so this is the cluster. This is your AKS cluster, and what happens is that I think so. Just Okay, just assume that these two guys are inside a cluster. I just add a thin line which would differentiate, and this is the this is your cloud hosted database, any service which you have just provisioned. Okay, and what happens is there is a user. This user this user is using the front end. Okay, this user is using the front end and is communicating via his browser. Okay, via his browser he is issuing commands or using the features on the browser, and that request is directing to front end. This front end is calling the back end. Okay, and this backend is then querying the database. Okay, querying the database, whatever the logic is. So for example, basic example, we'll say that in the search field, there is a search field in the browser for this application where you enter a name, okay, to find the product. It's a sports website, you can say, and you're just searching for a cricket bat. Okay, and this particular request goes to the front end, and from front end it calls a backend which holds which deals with all the search operations which is being performed. This is the API layer. This API deals with all the search operations. So what will happen is your request will go to the front end, and it will be cricket bat in the search field. This particular search field will go to this particular API. This front end will trigger a backend API. This API will say, okay, search field is cricket bat. Okay, and what it will do, it will query the database. There would be a database query, a particular database query to fetch all the bad things, details, price, and all. It will fetch it from the database. Database will reply to that this backend. This backend will forward that same reply to the front end, and basically once this reply comes back, the user layer, which is the browser, the browser will get the response. Okay, this is the basic flow. But what if this guy sends a string, which is a database command, to retrieve every table, column, every detail of the database. Okay, he just enters that particular string, or that particular database command, database script, right into the search field where he was searching cricket bat. He will create a malicious database script which will reveal every information, every column, every detail of the database. So he will just issue that. Front end will receive it. A scenario where there is no input validation. Front end will receive it. It will just blindly take that request, and it will blindly send that request to this particular backend. Backend will also take that input, that particular input. It will not validate, and it will pass to the database. Database just gets a command, set of commands, right? He is getting set of commands, and he will just respond back the output. So he is now what he has given. He is not giving list of cricket bats. He is giving the commands which was initiated by the attacker, maybe to reveal every detail of the database, every column and rows and columns, and this will be then relayed to the attacker's screen on the browser. So here there was.
Mohammed,
Mhm,
is
mhm.
this SQL injection, right?
Yes, this is SQL injection, basically. Okay, this is SQL injection. So basically, SQL injection is happening. Why? Because there was no input validation. So if you validate in the code itself, the coders have to do all these things, right? It's on them. Like their code should validate any malicious script. For example, you know what input you can get. I can get cricket bat, cricket ball, this, that. As the way you said, strings. You will just get alpha characters, not even numeric. You will just alpha characters. So you will accept only alpha characters, and rest everything in the world you will deny. Every characters, special characters, or numbers you will deny. You will just accept the alpha. What do you say? The alpha values. Okay, so this is input validation. Same thing should happen here also at different layers. This is called boundary validation. Once the traffic or the data goes from one microservice to another microservice, that is called boundary validation. So all these things will be learning in security architecture review properly, thoroughly. You don't worry upon that. This was a further topic which I took just now so that you understand this concept a bit more. Okay, that's why I just focused on this. So this thing is clear, right? For this thing, even a basic understanding, whatever I have said, you have understood this, right?
Yes,
Yes,
Mohammed,
it's
it's
clear.
clear.
Yeah.
Perfect. So let's come back to our example of wired SecOps. So if you see, just take this vulnerability which was here as a SQL injection vulnerability without input validation in the code. There was no input validation in your code. That was the vulnerable part of the code which you were talking about. So So now the thing is that this particular SAST will check that part of the code where it will say you are not validating the input which you are receiving from your front end, or from the user. Okay, the input is not being validated, whatever you are taking inside. Okay, so here SAST will point out the point of code which is having that vulnerable line where there is no input validation. And what will dash do? Okay, so what is DAS? DAS is basically dynamic application security testing, where you are testing your application or your microservice by sending malicious packet. Okay, and then studying the response, and then you determine, okay, this is a vulnerability. You are not just scanning the code, you are just sending malicious packet to your application. So when you can test dash test can be introduced in the DevSecOps once your application is deployed to a staging environment. I wouldn't say production. This should never be done in production. Okay, no test should be done on production. Out of this, just remember this thoroughly, that out of all these security mechanisms, only this security monitoring and ATP should be there in production. Nothing should be there in production apart from this. That will break your environment terribly. Okay. So what will Dash do? Dash will test your application once it is deployed to a particular environment. So basically, Dash will come into picture when your application is capable of handling TCP request and response, HTTP request and response. So definitely that becomes possible once it's deployed to some environment, right? It's having the networking capabilities, it's having the TCP/IP socket layers, everything. So in that scenario, your application will be eligible for a dash test. So what is this dash test? This dash is basically, this is also an application. Okay, you run it in your cluster itself. You should hit dash internally. You should hit dash internally. Internally means internally. There shouldn't be anything in between. Anything in between. So for example, dashed also will cover thoroughly, but it shouldn't go bouncer to you as of now what I'm saying. So a quick representation I will give of a typical architecture of an application, security application. Okay. Um, so you see, this is your application, this is your cluster. Okay, this is your app, and the triangle square, this square is your cluster, a case cluster. Okay, and what happens is you place multiple things like firewalls, okay, and DDoS protection, and you could say any other layer of security, right? And then you expose your application. There are a lot of things in front, okay, in front, which protects your application, and then the traffic goes to your app, to your the exact pod which is running in the cluster. There are a lot of things it needs to traverse through these security mechanisms. For the most common thing you can take is as a web application firewall. Web application firewall is something which sits right in front of your application facing the internet. So in that scenario, your dash would be nullified. I want to test my application for vulnerabilities. If somebody is sitting, if somebody is sitting here inside my cluster or inside my cloud environment, not outside the internet. Okay, not on the internet, not outside my cloud environment. He is sitting somewhere inside. Okay, so here what will happen is you are testing your application. If the first level of security is breached, at that point, if somebody gets in and checks for vulnerabilities, okay, loopholes in your environment, at that point how much exposed you are, at that point how much exposed you are. So you are assuming that the attacker has already passed all these WAF and firewall things, and he has got into our cloud environment, or he has got into our cluster environment. Okay, he's already inside and sitting from here. What vulnerabilities you can say? So the right example should I give you is that, for example, SQL injection. He will test for SQL injection. Okay, but once he sends SQL injection packets, malicious traffic, he is generating from a tool and he is sending to your application. These traffic gets blocked here in the WAF. Okay, these thing gets blocked in the WAF. We'll check this practically also. I can show you two ways where you hit it internally and externally, how WAF is blocking your traffic. So because basically that is malicious traffic and WAF is made to block the malicious traffic. So the you will run a test and you will say, okay, Dash said that my application is secure. He didn't find any vulnerability, but you don't know the reason. The reason is that not your code is secure. The reason is your you have a gatekeeper just right in front of your infrastructure, which is blocking that malicious traffic and telling the tool that okay, there is no SQL injection vulnerability. So if you test it from here, no, and you have missed that SQL injection input validation in your code at this point of time in the SAS, then you can catch it in Dash if and only if you are hitting it from inside the cluster. So what this Dash does is you run a pipeline. Same approach we'll take. We'll run a basic simple pipeline where you have configured all the steps to run the Dash. So what will happen is while that particular pipeline runs, that particular pipeline creates a container or a pod of that particular tool. For example, we will take OWAF Zap. OWAF Zap is a Dash tool. A OWAF Zap container will be created here, and then from here itself it will test it internally right within the cluster. You shouldn't give the entire URL also, the URL which public is using, right? abcd.com. No, the internal URL you can give the service URL as well, like within the cluster itself. So you need to give the pod name, the namespace name, and the cluster name, and done. This particular pod, the dash pod will be able to communicate with your app. So don't worry on this. We'll cover this thoroughly just for your this part of understanding that dash will catch your vulnerability. Okay, here, and then you will get a response. Okay, that okay, dash tool has this pipeline has failed because there were these many vulnerabilities, and your application which is deployed in this particular staging environment has been flagged as vulnerable. Okay, so you see, if you leave it here, you can catch it here. If you leave it here, you can catch it here. Okay, and even if you left it here, dashed, you would say I don't want to take the dashed approach also. Then there is some VAPT happening in your organization. Most of the organization does it externally from external parties, which can give them a VAPT certificate. Okay, we have done this VAPT and we are safe. Well, because this particular organization, which is ISO certified uh, mm, or acclaimed by some organization, some framework, they have given us a certificate that we are safe. So you do a VAPT. Now what will happen is he will attack you. He will attack you based on your entire just the way an attacker would from outside. So first, what he needs to do, he needs to bypass this WAF controls. Then he needs to get in. Then he needs to attack your application and check. Okay, there is an SQL injection vulnerability. So there are different layers of protection which you are doing here. So that is the actual importance of security in DevSecOps, and you should implement it at every stage. So you would say, okay, what benefit I got from Lint, SAS, and Dash. Okay, I could have caught it in the VAPT itself. In the VAPT itself, I could have caught it. Okay, so the answer here is you you find a vulnerability in the VAPT while your application is already in production or in some staging environment. Okay, so what you need to do is you found a vulnerability, then you need to go back here to your developer, ask your developer to again code it. He will again code it, he will again test it, he will again push it. He pushes it gets built, and then it again goes to release, and after release it goes to staging, and then again it goes to all those pain, right? That unit testing, performance testing, this testing, that testing, lot of things are there, right? To cover. So how much time you wasted and how much resource you wasted. Okay, so this is the thing, right? You wasted a lot of time, money, energy, everything. So even if you would have caught it here itself, if you would have caught it here itself, you wouldn't have to worry about all the process which I just explained, right? Again coding, again deploying, again testing. So this is what we called as shift left, shift left approach. Shift left, you must have heard about, it's very common thing now in market. Shift left says before your application is deployed to a staging environment, you should catch the vulnerabilities. That is called shift left. So basically, what is shift left? While your microservice is a code, is already a code, okay? Your microservice is already a code. At that time itself, you should catch the vulnerability and remediate it, and then redeploy it. Okay, I wouldn't say deploy because you have not gone to the deploy phase, but you should catch the vulnerability in the coding phase itself. So if you see here, in this, these are the security mechanisms, right? So these security mechanisms, these are basically the shift left things, where you are just the one in the plan, code, and build phase. All these are the shift left security mechanisms, which is the early detection. Shift left, it is nothing but early detection of vulnerability. So here, if you see, early detection would be the linting, the SAST, till your code is not. Even in SAST also, again you need to go through this process of pushing it and then pull request, and this also wastes time, right? So, so this is the importance actually of security in DevOps environment. Basically, what these things you need to follow for a secure deployment. So, any questions here?
No, so far got the
No,
overview.
it's clear.
Okay. Okay. So, this sums up our today's lecture. Okay, I would just want you guys to just go through the things, read articles, few articles. Just spend 30 to 45 minutes on what DevOps is, what DevSecOps is, what shift left is, whatever we have talked about. Just
Yeah,
read it on internet, and reading the articles will expand your knowledge of security exponentially, rather than just taking lectures or watching videos. Articles is the best thing which will help you out. Okay,
yeah.
but definitely it should be combined with some study material. Okay. Mm, okay,
Sure. Would
so
you suggest any site or link, Mohammed, for?
no, no, no. I wouldn't. If you are not
Mhm.
understand the topic, I would recommend you read it at 10 different places, and and
Sure.
you
Yeah, I
uh,
think yeah, that would be good.
yes,
Yeah.
and you would be so much clear and proficient in that particular topic that it
Yeah.
will stay with you forever in your mind, and you would understand it thoroughly.
Yes.
So I want
Right. Right.
I want you guys to go through these things, the security part, whatever we discussed, and just
Okay.
an overview. I will give you like what we will be. So this is for the next part. I thought of covering this today, but that would be too much actually to digest.
Yeah.
So yeah, so I will just go through the course once. What we will be doing there is this was the first part. Okay, security and DevOps, right? What it is
Mhm.
exactly, what things are there. Then there are few security concepts, I would say, which you should know so to expand your knowledge in DevOps, in DevSecOps. So for example, if you run a tool, I taught you everything, right? How to run a tool, security things, X, Y, Z. But there are a lot of there are outputs, right? Outputs to that tool. So you should be able to understand that outputs, like what it is, what vulnerability is, what it's saying, what this tool is trying to say, why he flagged this particular thing as a vulnerability. So for that, I will be just cutting it as much as possible. The required things I'll be just throwing at you of security, which I believe
Okay.
you should be proficient with. And then
Yeah.
there goes the DevOps DevSecOps model and defense in depth. These two topics, if you see, I have covered it here also, and specifically with DevOps also. So these four things are very much crucial, very much crucial. And once you understand these four parts, all these are tools, security mechanisms. These would be the things which I'll be showing you practically. So this is very piece of cake. If you understand the above four, you can handle everything below this till the 21st easy. So this would be the flow we would be following.
Okay.
Okay.
Okay. So again, I am asking any questions. Please feel free. Okay. Uh, don't hesitate.
Yeah, this was a good introduction overview.
It's clear.
Yeah, good orientation. Clear so far.
And any doubts you have, any questions, you can ping me directly on WhatsApp any time of the day. No issues. I
Sure,
work from
sure.
home only, yeah, so perfect.
Okay.